Okay, this is exam 4 for physics 102, spring 2014. First, we have a current going through a loop. That current is going in this direction. And I want to know what is the direction of the force on this side, labeled B. All right, so my current is in this direction. My magnetic field is in this direction. And so the force is into the page. That is B. Positively charged particle and its magnetic field is shown. What is the force acting on the particle? All right, well, again, V in this direction, B in this direction. We know it has to be either into or out of the page. It's going to be out of the page, the force. So B here. Which of these statements is true? Magnets have only a north or south pole. That's not true. They have both always. North poles of a magnet attract. That's not true. They repel. And wood is ferromagnetic. That's also not true. So none of these are true. Sigurd shows how the path of a charged particle, what is the direction of the magnetic field, has caused this motion. All right, well, the force is up. All right, that's what causes this upward motion. The velocity is to the right. So that would give us a magnetic field that is into the page. However, it is a negative charge. So we're going to nix that. And we say that the magnetic field is out of the page. So A is 4. Magnetic field a distance of 0.02 meters from a long current carrying wire is 2 times 10 to the minus 5. What is the current in the wire? We'll go to our equation sheet here. We're looking for the magnetic field due to the long straight wire. That's right here. V equals mu naught I over 2 pi r. So that's going to be 4 pi I, we don't know. B is, actually, I'm going to do this a little bit differently. I forgot I was looking for I here. So I'm just going to go and solve for I, and then we'll put in the numbers. That's going to be B 2 pi r over mu naught. B is 2 times 10 to the minus 5 Tesla. R is 0.02 meters. And divided by mu naught, which is 4 pi times 10 to the minus 7. All right, so let's see, my pi's cancel. I have my 2's here will cancel here. So, and then I get a 10 to the minus 5, leaving me just 10 to the minus 2 here. So that's going to be, you can put this in your calculator, but it's equal to 2 amps. That's 0.02 times 10 to the 2, which is 2 amps. So D is the right answer. Magnetic field lines inside the solenoid switch, inside this solenoid, or what? Inside of it. Inside of it, the field lines are going to go here. I let my thumb go in the direction of the current, and then my fingers would fold around and give the magnetic field, which would be traveling up towards the top of the page. A 2 coulomb charge moves freely in a circular path, has that mass, takes that time to complete 1 revolution. What is the magnitude of the magnetic field? All right, let's just start. We'll start with the cyclotron equation. R equals mv over qb. I'll solve that for B, which is what I'm looking for. It's going to be mv over qr. V isn't given here. You had a homework problem very similar to this, or basically identical. V is equal to the circumference, 2 pi r, divided by the period, and then you have QR here, so we can get rid of the R's. All right, so we have the mass, which is 0.01, 2 pi, divided by Q, which is 2 coulombs, and T, which is 0.0314 seconds. All right, let's see, the 2's cancel. Actually, you can see here that the pi would cancel here, but I'll leave you to work that out on your own, and you just get 1 Tesla as the answer for number 7. Let's see, that's B. High voltage power line carries about 100 amps. What is the magnetic field 20 meters from the line? Let's see, I think we have one already like this. This is B equals mu naught I over 2 pi R. All right. And here we're looking for B, so that's 4 pi times 10 to the minus 7. I is 100 over 2 pi times R, which is 20 meters. You got a homework problem identical to this, basically. The pi's cancel. 2 will cancel here, giving me a 2 up there. This 2 will cancel with that 2, that 10. So we're just looking at 10 times 10 to the minus 7 Tesla. All right, let's see, they're all given in micro Tesla. You can write this out if you want. It's going to look like this: 0.00000, 5 zeros and 1 0. So I started here and moved over 7 spots. And that's going to be, if I convert it to microtesla, 1 microtesla. So B is the right answer. Okay, this is a mass spectrometer. There's the velocity, magnetic field, and the radius. I want to know which of these particles, these imaginary particles. Well, R equals mv over qb. That's my cyclotron equation. I'm going to solve for the mass to charge ratio. Rb over v. R is 0.5 meters. V is 2 Tesla. And V is, what is V? 2 meters per second. Now, these aren't very realistic numbers. I just use them to make it easier for you, but your charges will be going much faster, much faster than this. And so we'll get a mass charge ratio of 1 to 2. And now I want to look and find out what are the mass charge ratios. Well, here my mass to charge ratio is 1 to 2. Here it's 2 to 1, 4 to 1, and 6 to 2, or 3 to 1. So delirium is the right answer. That's A for number 9. Particle in this mass spectrometer is traveling. What direction will it initially travel? Okay, well, our velocity is in this direction. Magnetic field is into the page, and so it's going to cause a force initially in this direction. And it's actually going to cause a circular path like this. All right, so the force is down. Number 10 is B. Electron is traveling at that speed in magnetic field with a magnitude of 2 Tesla. What is the magnitude of the force on the electron? All right, well, this is F equals QVB. I'll leave off the sine theta because it's orthogonal. Charge is 1.6 times 10 to the minus 19 coulombs. That's on your equation sheet. V is 1 times 10 to the 6 meters per second. And B is 2 Tesla. Let's see, that's 3.2 times 10 to the minus 13. So B is the right answer for number 11. For an electric motor to function properly, what must happen? Let's see, the current, that doesn't make any sense. The current must change directions every half turn of the armature. Okay, that is correct. Let's look at these others. The current in the motor must be bigger than the current in the magnets. Again, that doesn't really make a sense. And the magnetic field must point upwards. Okay, it might point upwards, but not necessarily. Electrical charges and magnetic poles have many similarities, but one difference is which? Okay, opposite magnetic poles repel. That's not even true. Opposite magnetic poles attract, and the same is true for charges. A magnetic pole cannot be isolated. Okay, that is true. Unlike charges, magnetic poles can be isolated. One magnetic pole cannot create magnetic poles in other materials. That's not true either. I can take an otherwise non-magnetic ferromagnetic material and magnetize it with a permanent magnet. You know, like you take a nail and you put it on a magnet and then it becomes a magnet. Magnetic poles do not produce magnetic fields. That's not true either. Magnetic pole of the Earth, nearest the geographic North Pole, corresponds to which of the following? All right, remember, here's the Earth. This is the North Pole. This is the South Pole. But if I imagine the Earth having this great big bar magnet, this would be the southern magnetic pole, and this is the northern magnetic pole. All right, so the answer is magnetic South Pole. All right, positive charge approaches a wire with a current, 1 amp flowing with it. Charge is directed to the left, as in this figure. What is the direction of the current? All right, well, first, I have a velocity that's in this direction. and then it feels a force that is in this direction, that's off to the side, to the left. All right, so that tells me that my magnetic field that causes this has to be into the page. In order to be into the page, I have to have a current that is in that direction. So what is that to the right? For 15 is B. All right, how are natural magnets created? It's going to be D. Molten metal solidifies in the presence of a magnetic field. And the Earth's magnetic field plays a role in which of these atmospheric phenomena? That would be aurora borealis. Consider the light rays that travel these two media. Which of the two statements is true? Looking at their indices of refraction. Remember, we draw our wave fronts. We know here it's... Hold on just a sec. Okay, sorry about that. So we have our wave front here. And here we know that it has to slow down, and then it's going to speed up around here so that the wave fronts travel like this. And so if it slows down in N2, that means that N2 is bigger than N1. So let's see which are, okay, so that's C is the right answer for number 18. All right, number 19, let's see, light ray incident, air to glass boundary. So here I have air on this side, glass on this side. It tells me that the angle of incidence over here is 30 degrees, and then the angle of refraction is 21 degrees. And I want to know what is the index of refraction of glass. Okay, index for air is 1, so that's going to be N1 sine theta 1 equals N2 sine theta 2. That's 1 sine of 30 equals N2 sine of 21. And then we solve that for N2. Let's see, I'll do that down here. So N2, the 1 goes away. It's going to be sine 30 over sine 21. I get 1.395 or 1.4. So A is the right answer for number 19. Ray of light travels from liquid to glass. So my liquid is right here. My glass is right here. The index for here is 1.75, and the index for here is 1.52. And I want to know what is the critical angle. So what is the angle here that will cause this angle to be 90 degrees? What is the critical angle? First of all, I just want to ask myself, are these indices of refraction correct? And it'll have to travel faster in this medium down here, and it does because there's a lower index of refraction. So then I say 1.75 sine of theta critical is equal to 1.52 sine of 90, but sine of 90, of course, is 1. So theta critical, the inverse sine, I get 60.3. So C is the right answer for 20. Consider this range of mirrors. What is the angle of reflection off of mirror 2? All right, well, I know that this angle has to be 50. If that angle is 50, this angle has to be 40, and this angle has to be 180 minus 60 plus 40. That's 180 minus 100, so that has to be 80 degrees. It looks really steep. And then that means this angle has to be 90 minus 80, or 10 degrees, and then it's going to reflect off at 10 degrees. So the angle of reflection off mirror 2 is 10 degrees C. Organize these in order of shortest to longest wavelength. The shortest wavelength is gamma, the longest is radio, and then let's see, the next shortest is ultraviolet and visible. So gamma, ultra, visible, and radio. Gamma, ultra, visible. It looks like A is the right answer for 22. All right, Newton explained light as a particle because of reflection, and Huygens explained light as a wave because of refraction. All right, particle, reflection, wave, refraction. Looks like C is that for 23. And here we go. What color will be bent or refracted the most in a prism based on this figure? Well, first of all, what do these wavelengths correspond to? This is red, and this is blue. And then in between, we have orange and green. So here's orange, and then this is green. Remember Roy G. Biv in this direction. But obviously blue or red are going to be answers, which will be bent the most. And the one that will be bent the most will be the one with the larger index of refraction. So that's on this end of the spectrum, so that's going to be blue. So if I have white light coming in, my red light will be bent like that, and then my blue light will be bent a lot more because the index of refraction is bigger. And then the orange, yellow, green, blue will fall in between. All right, this is a fiber optic cable, a light ray coming into the acceptance zone. So light rays coming into this zone will actually enter the fiber optic cable and be totally internally reflected. But what must be true about the indices of refraction? We've already seen this a little bit, but you have to have a big index and a small index. So you have to have a high index of refraction and a low index of refraction. Remember, this is because you want that light ray to bend away from the normal, and so it's going to be traveling faster here to bend in that direction. So high index of the core has to be bigger than the cladding, so that is C. And the last one, speed of light is 3 times 10 to the 8th. Glass is an index of 1.5. What is the speed of light in glass? So V is C over N. That's 2 times 10 to the 8. A is 26.